Hello everyone and welcome to this new video, and in this video we will continue with our equations in the complex space C, and we will try to solve another equation. And as usual, before we actually start with the content of the video, I would like to thank you for all your support, and I warmly invite you to continue with your support and subscribing to my channel, hitting the bell button to stay always updated. And if you want to help me in a more substantial way, you will have in the description below the links to my PayPal and to my Ko-Fi, and you can help me with a liberal donation there. So this is the usual YouTube incipit, and I have to do it for obvious algorithmic reasons. And now we can start with the content of our video. So as we have anticipated, we want to solve the following equation in C. So this is our equation. We have z minus I squared times z star plus I, and this is equal to 9z minus 9I. So the most convenient thing to do is to take the right hand side of the equation and put it to the left hand side, basically because we have this z minus I which appears both here and here. So we perform this calculation, and we have z minus I squared times z star, which is the complex conjugate. Okay, sometimes I will use also z bar to indicate the complex conjugate, but I can hop between the two. Okay, so z star plus I minus 9, which multiplies z minus z minus I, and this is equal to 0. So now we have z minus I here, as we have anticipated, and we have another equal factor here, so we can factor it out as follows, and we have z minus I, which multiplies this whole expression, and we have z minus I, this was squared. Okay, so this multiplication here reconstructs this square here. Then we have z star plus I minus 9, because this is the whole factor here, and this is equal to 0. Okay, perfect. So now we have the equation in a form that we can actually use to infer the solutions. So the first solution is quite easy, because if for the product rule, if we make this factor here equal to 0, the whole expression also becomes equal to 0. So the first solution, we can say it here, the first solution is z equal to I. And so we have the first solution. Okay, now we have to make this whole expression equal to 0, so we can focus our attention on this expression. So we have we want to have z minus I and z star plus I minus 9 equal to 0. So now we can express z in its algebraic form as x plus I y, and so we have x plus I y minus I, which multiplies x minus I y plus I minus 9 is equal to 0, and then we can factor the I term, and we have x plus I times epsilon minus 1, and this whole number also multiplies x plus I, and on the contrary here we can factor out a minus I. In this way we can see what kind of structure actually emerges. So we have x minus I, which multiplies epsilon minus 1. Okay, perfect. And this is equal to 9, minus 9 is equal to 0. Perfect. So now we see that we have here x and x, while the imaginary part is the same apart from a sign. So we have that this number is the complex conjugate of this other number and vice versa. So basically what this exercise is telling us is that if we pose w is equal to x plus I epsilon minus 1, and so w star is equal to x minus I y minus 1, basically here we have this expression. We have this factor here is w, this other factor here is w star, and w star minus 9 is equal to 0, which means that w multiplied by w complex conjugated is w modulus squared is equal to 9, and this means that we can write that w is basically all those numbers whose modulus is equal to 3. So we have understood that basically the set which actually nullifies this whole expression is a circumference of radius 3, but we have now to determine where it is the center of this circumference. But we can see it here. Basically it's written here, because we have to remember that our number is basically x plus our unknown number. It's basically x plus I, which multiplies y minus 1. So basically this whole expression okay, can also be written as follows. So we have that w is equal to x plus I epsilon minus 1. So w modulus squared is equal to x star plus epsilon minus y minus 1 squared, and from the equation we have seen before, this is equal to 9. But from basically elementary geometry we remember that this is nothing but the equation of a circumference of radius r equal to 3 and center, which is codified in this expression, which is 0 and 1. So this is the center of our circumference. So the complex number z, which actually yes, we return to z, which actually solve the equation, are z minus I in modulus is equal to 3. So we can finally because in this expression basically we have written all the solution that we have also written here recalling that w is x plus I, which multiplies y minus 1. Here z is the general complex number in C. So we can write out all our solutions. So the solutions are, so we have the first solution that we have found, which is z equal to I, and we write it as a set union all the z in the complex space such that z minus I. So in this way we are capturing all those complex numbers that have basically all those complex numbers that live on the circumference of center 0, 1 in the complex space and radius equal to 3. And this whole set solves our equation. So for this video on complex equation, I can close it here, and as usual I would like to thank you for your attention, and we will see on the next video. Thanks for watching.